So I'm going to use the integration by parts formula twice to solve one particular integral. And this is a particularly nice integral, and it's a nice example of how you can use integration by parts twice in order to get back to the original integral and then solve the problem. Let me show you what I mean. So we're going to start off with the integral that I want to solve, and I'm going to have e to the x times sine x dx. And first of all, we need to decide, well, okay, here's my integration by parts formula. So what am I going to choose to be u, and what am I going to choose to be dv by dx? In actual fact, in this example, it doesn't matter which way round you do that. So I'm just going to choose one particular way of doing it. I might as well do it the way that I've written it. So I'm going to make u equal to e to the x. And then I'm going to have dv by dx equals sine x. And now I can do du by dx is e to the x. And v is minus cos x. Because cos, when you differentiate it, it goes to minus sine, so minus cos will go to plus sine when you differentiate it. So that's my variables that I'm going to substitute in. I could have done this the other way round. I could have said that dv by dx is e to the x, and then v would also be e to the x, and I could have said that u is equal to sine x, and then du by dx is going to be cos x. It's going to be very similar whichever way round you do it, so I've just chosen to do it this particular way. So let's substitute those in. So I'm going to have, this is my integral, let's call it capital I, that I'm trying to find. So I've got the integral of u dv by dx is u times v, so that's minus e to the x cos x, minus the integral of u of v du by dx, v minus cos x, du by dx, e to the x dx. Now, at first glance, you look at this and you think, well, that doesn't really help me very much because I've still got an integral that I can't solve, or I'm going to have to use integration by parts again. Well, the nice thing about it is hopefully you can see that I've tried to integrate e to the x sine x, and I've got an integral involving e to the x cos x. I've just got an instinct that if I do integration by parts on this integral, I might get back to e to the x sine x, and that might be quite helpful. Let me show you what I mean. So we're going to now substitute in again, and again it doesn't matter which way round I do this. I'm just going to choose u to be e to the x and dv by dx to be cos x. So u equals e to the x, du by dx is e to the x, and dv by dx is cos x. So v is equal to sine x, because when I differentiate sine I get cos. So let's substitute those ones in and see what we end up with. So I'm going to have equals minus e to x cos x plus, now the integral of u dv by dx is uv, so that's going to be e to the x sine x, minus the integral of v du by dx, which is minus the integral of v du by dx is e to the x sine x, and you may think, well, that really doesn't help me very much because I've still got an integral that I'm going to have to do integration by parts. But hopefully you can see that this was our original integral that we started with. So actually what I've got here is now a formula for my original integral, call it capital I, is equal to e to the x times sine x minus cos x minus my original integral, which is my capital I. And now I can just bring my capital I over to the left-hand side. So I'm going to say that twice my integral is e to the x sine x minus cos x. So my original integral that I was trying to solve is e to the x over 2 times sine x minus cos x. And that's my answer. And I mean, and I probably should put a constant of integration. When you see a linear combination of sinusoidal functions, sine and cos, then you might know that you can combine that into a single sine function. I won't do that in this video, but it's something else that is in the A-level syllabus. So there we have it. So what we did, we started off by looking at this integral. We noticed we had to use integration by parts, which we did. It didn't seem to help very much because I still got e to the x cos x, which looks as complicated as the thing I started with. But then by doing it again, I can get back to the integral I started with. And now we've got a formula for that integral, capital I, that I was trying to solve. So 2i was equal to that, and therefore you can solve it for the integral. So I think that's a particularly nice way of using integration by parts, and this periodic function sine x going to cos x and then going back to sine x is very helpful in these circumstances. So I hope that helps. If you've got any questions or comments, please leave them in the comments section. Thanks.